Okay, so this is our dinitrogen trioxide, which has 2 nitrogens and 3 oxygens, and it's asking how many molecules are in this specific amount of grams. So we need to go, we're basically converting, we're going from grams to moles. And so we need to get our molar mass first, so that way we can go, we'll start off with our 33.3 grams of N2O3, and we're going to try and get to moles. So we got our 1 mole up top, but we need to find out our molar mass right here. So we're going to get our nitrogen, and that's 14.0067, and so there's 2 of those, and then we're going to add it with our oxygen, which is like 15 point, what is it, 99? Yeah, 3 nines, and there's 3 of those. Let me get my handy dandy calculator, which is on my phone. Calculate that. Which is 14.0067 times 2. So that number, that's 28.0134 plus our 3 oxygens, which is 15.999 times 3, which is 47.997, that number, plus our nitrogen, which is 28.0134, which gives us our molar mass, which is what we need to convert from grams to moles. So we use that up here. So we get our 76.0104 grams of NO2O3. So our grams will cancel. And then what we're going to do is hold on, let me delete all my calculator. So our grams, 33.3 times 1, which is easy, the same number, and then divide by our molar mass, which we will do, calculate, 0104, which gives us 0.43, and we're going to use 3 significant figures, so 0.38 moles of N2O3. So now we have, this is how many moles there are, which is the first part of that question. Then the second part is how many atoms are there. So now we need to go from moles to atoms, which is, let me refresh my brain. Isn't that, you start off with your moles. So up here is grams to moles. Then down here, we're going from moles to the number of atoms that we have, which will start off with our moles. 0.38 mole of our N2O3. Oh, 3 is down here. And now we're trying to find out the number of atoms. So basically what we're going to do is multiply by Avogadro's number, which is 6.022 times 10 to the 23rd mole right here. N2O3. So our moles cancel, and then we get, so we're multiplying our moles by Avogadro's number to see how many atoms of dinitrogen trioxide we have. So, calculator. Go up to it and clear all that. Times 6.022 times 10. Oh, my calculator won't do that. Do you have a calculator that'll... My phone calculator is the basic calculator. I don't have a calculator at all. That's fine. The scientific calculator will work. Yeah, they only let you use these ones, so we'll go 0.438 times 6.022 times 10. Where's the up button? There's a little up button. 23. So we hit enter. And there you go. It's that little number right there, which is 2.637636 times 10 to the 23rd. And that's the atoms of Na2O3, which I guess you use 3 sig figs. So boom, boom, boom. Around that, which is 2.64 times 10 to the 23rd atoms, or however it is, atoms, AMU, or something like that. But that should be how. Molecules. Yeah, I think so. I think they say atoms so that way you can get the difference. Because if you just had molecules and you just wrote MOL, it's like the same as moles. So that's why they do atoms. Now we can go over here. Luckily, oh yeah, for Hagigi it's molecules, so just use molecules. So yeah, just use whichever one she wants. Yeah, for this test, it's important to know the groups 1 through 8A, your solubility rules, and then how to convert from moles to, or from grams to moles to molecules is how she says it, or atoms or whatever. Or there's also, and then converting backwards for some of those. Just looking at the rest of these. And then balancing your chemical equations is important too. Yeah, if you go over all the chapter reviews and go through the whole thing, then you should be fine for the test, because that's all the material she covers, and I wouldn't worry about much else after that if you do all of her reviews. But other than that, that's all that we have for today.